All right, in this episode, we're going to continue to talk about the rationalization, right? We've done some examples in the previous episode, and here we're gonna look at another example that's from the homework section, okay? And this is on homework on rationalizing the numerator, the denominator. And this one, I pick question, the last question. Okay, the last question would be root A plus root B and root A minus root B. I'm going to make the fonts a little bit larger. Hold on, 175%. All right, to rationalize the denominator, we need to get rid of the radicals in the denominator. The correct way of doing this, okay, which I'm going to talk about first, and then we're going to address some of the possible mistakes. If you want to do it for yourself, by yourself on the side, you may like to pause the video and just do it on your own and then come back to watch it, which I highly recommend. The right way to do it is because we want to rationalize the denominator. So we're going to try to find the conjugate for the denominator. The conjugate for the denominator is root A plus root B. So this will be the number 1. So this will be the quantity 1 we have selected to rationalize the denominator. And then, right? The denominator, we will have numerator times numerator. So numerator times numerator, we have numerator times numerator, denominator times denominator. And this pair are conjugates. The denominator, we have conjugates. With that conjugate, we know that we have, if there's A plus B times A minus B, it will be equals to A squared minus B squared. All right, so in that regard, we're gonna get, in our capital A is root A. Capital A is root A. So capital A is root A. And our capital B is root B. There. Okay, so as a result, it's going to equals to A minus B. So the radicals are rid of, so no longer have the denominator. The denominator no longer has the radicals. Okay, the numerator, however, okay, we haven't touched the numerator. The numerator is root A plus root B, multiply root A times root B. So it's really just root A plus root B to the power 2, if you wish. So on the next step, okay, on the next step, we will have, so let me get rid of this thing here. So let's make it look a little bit better, okay? Oh, it doesn't do it. But anyway, so we will have A minus B in the denominator, and on the numerator, we have to be very careful, okay? A common mistake okay? A common mistake, which we see very often, okay? People would do, which is a square, they would do this. This happens a lot. This is a common mistake. It's a terrible mistake. So what should be done then? What should be done then? It should be foiled. It should be foiled, okay? It should be, okay, if we recall the formula, a plus b squared is equals to a squared, which we talked about this in the last episode, right? And plus b squared. So what we have here is that not only we have these two, right? We not only have these two, we also have we have a middle term, 2 times root a multiply root b. So this will be the correct, okay? And then as a result, root a squared, that's a, plus, oh, here it should be a plus sign there. Sorry for missing it, okay? And then the middle term is 2 times root a times b, we can do that, plus b. So the final answer we have, foiling this guy, right? Oh, oops. Okay, we should be getting that equals to, in the end, right? We have a minus b in the denominator, and the numerator, we just get all of that. So that's the common mistake. This is a mistake. This is a mistake, right? So if you look at these steps, make sure you practice and know how to do this. Okay, there's a quiz question that will be, about this, about the similar questions. You really make sure you understand. I pointed out some common mistakes, but I don't know what to expect when you do it. So if you have any questions, please don't hesitate to ask. The next topic I want to take you guys to is number 6 in the homework, okay, which is simplifying. Simplify. I picked up these questions from a pre-algebra textbook. Okay, I thought they are pretty good for us to review some of those properties we have learned. For example, in terms of power, right? So let's just review the power. Review our questions about power. For example, we have b raised to the power of m, right? Multiply b raised to the power n. What should that be equal to? Right? What should that be equal to? And the other one is that if we have 8ab, right? We have one quantity, another quantity, and raised to the power of n, what do we get? Right? And one more is, suppose we have b to the power m, and then to the power of n, what does that equal to? Okay? Because we review these topics, and I don't wish just to give you a formula for you to memorize, and I want you to think and be able to derive it yourself. So for that reason, I'm going to put a couple more here, okay? And the other one is that what is b raised to the power of negative n? What would that be? Right? What would that be? So before we do any question on number 6, we're going to review on these topics. So I'm going to bring that down over here. Okay, so we're going to review about these power issues. Okay, so b to the power m multiply b to the power n. What does that mean? Well, b to the power m multiply b to the power n really means that we multiply b with itself how many times? M times. M times. M times. And then we multiply b to the power n. So b times b times b. So this will be how many times? N times. N times. So we will have b times b, m times, and then b times b, n times. So total, according to the definition of power, it's going to be b to the power of m plus n. Example, right? Example, suppose I have b raised to the power of 5, or let me make it 3. Multiply b raised to the power of 2. Right? What does that mean? It's being b times b times b 3 times, right? And b times b squared is another twice, right? So 2 times, so that's going to be b to the power 5. And b to the power 5 is really just b to the power of 3 plus 2. So we add these two exponents. So that's how you can figure out, right? Okay. So as a result, we know that when we have the same base, right? You can see they have the same base. Then that's what we got. That's what we have. And you know the reason why. You know the reason why. Okay, so that's one of the formula. Okay, so let's look at the other one, the second one. Okay. A is a quantity, B is a quantity, and then we have raised to the power of n. Take a similar example, right? So let's look at an example. Suppose I have A times B raised to the power of 3. What does that mean? It just means that A times B 3 times. 1, 2, 3. 1, 2, 3. Okay. And then if we, because multiplication comply with commutative property, so we can totally have A times A times A and times B times B times B. So in the end, what do we get? We get A to the power 3 multiply B raised to the power 3. So from this example, can we figure out about A times B to the power of n? Of course. So this just means that you're going to multiply A times B how many times? N times. N times. So this is total of n times. N times, right? N times. So with that, we just regroup the A. So we have A times A times A, right? That's n times. And we have B times B n times. So this will be n times, right? That's n times. And there's another n times. N times. So in the end, what do we get? We get A to the power of n multiply B raised to the power of n. right? So here we go. We have just derived another formula, but you can see we use the symbol A and B. In this situation, we have A and B can be different. Of course, they can also be the same, but in this case, typically they're different. Okay, they may be different and they may be the same. Okay, so now, how do you figure out what is b to the power m and then to the power of m, right? How do we figure that out? Well, let's look at an example. Suppose I have a b raised to the power of 3 and then raised to the power of 2. What does that mean? First, you look at the square, right? You look at the square. Is the parentheses being squared? So parentheses time itself, right? And then what do we get? B to the power 3 times b to the power 3. We know that's a b raised to the power of what? 3 plus 3, right? We have this guy, right? We have this property right there, so we can use, right? And therefore, we get b raised to the power of what? 6. Okay. Now, if we have b to the power m and then to the power n, how do we derive that? How do we derive that? Well, we first look at the n as a power, right? That means the parentheses time itself n times. So this is going to be n times n times, right? And then what happens? We can apply this property over here, right? So b to the power m. So we're gonna end up with b raised to the power of m. So we're gonna add n times m. So m plus all the way plus m. How many times has this m been repeated? n times, right? So this is n times again. So in the end, we get b raised to the power of what? M times n. So here we go. We derived another formula right there. Okay. Now, 3 formula derived already. Oops. Okay. Now, the next one, negative exponent. Okay, negative exponent. This one is a little bit tricky. This one, before we talk about negative exponent, maybe I would like to mention, what if the exponent is 0, right? E to the power 0, what does that equal to? Guess, okay? Maybe pause the video and guess it. Well, it equals to 1, but we have to require that b cannot be 0. Okay, so these two must be together. They must be together. Why? So let's look at b to the power 0 equals 1, how it is derived. Okay. Suppose we have a b divided by b, right? And we all know that this equals to 1, right? So we can put the 1 on the other side. And of course, we also want to address the other property, which we didn't quite do, is that suppose we have b to the power m divided by b to the power of n, and that's equals to b raised to the power of m minus n, right? Okay, so I'm going to leave that deriving for you. So 1 is equal to b over b, but we need to make sure that this b cannot be 0, isn't it? B cannot be 0. Why b cannot be 0? 0 cannot be denominator. B cannot be 0. Okay, and this is b raised to the power of 1 minus 1. So this is b to the power of 1 minus 1. Therefore, that's b raised to the power of 0. So that's why b to the power 0 equals to 1, provided that b cannot be 0. So this attachment is absolutely necessary. It's absolutely necessary. So with that said and done, so let's look at the negative power. Negative power actually is rather tricky. It is defined as 1 over b to the power of n. Okay, so this is a definition. This is definition. What does it mean then? What does it mean then? Okay, so let's look at some examples. Okay, let's look at some examples. Well, what does it mean as 2 to the power of negative 1? Right, b is 2, b is 2, n is 1. And here we have a negative 1. Well, that's going to be just 1 over 2 to the power of 1. So it's really what? It's really 1/2. Right? Now, what is 3 to the power of negative 2? Well, it is just going to be 1 over 3 squared. There you go. So that's going to be 1 over 9. So you guys can practice on this, okay? So now we can start working on simplifying some expressions in number 6, right? So I'm going to bring all the formula here that we have derived, right? So this one, and what else? B to the power is 0. Whoops. Right, just in case we need any one of them. This one we didn't quite derive, but I'm going to leave that for you. Right, I'm going to leave that for you. Let's see what else. This guy here, right? Useful stuff. You don't want to, we don't want you to kind of memorize everything. There's too much to memorize. Derive it would be the best way to go. Okay, once you derive it, you know where it came from. You never have to memorize. Okay, so without further ado, let's look at some of the examples, some of the exercises in number 6, okay, in your homework. The first one I look at is 2 to the power of negative 1 plus 3 to the power of negative 1. And then there's a negative sign outside the parentheses. And the number 2, we have everything almost the same. But this is a multiplication. Haha. Okay, so these questions are placed there intentionally so you can tell the difference. You can see all of these formula here. Okay. There's no such a situation, but there's a situation like that. Okay, so they're all multiplication. Between this is a multiplication. Okay, and multiplication or division. There's no multiplication here. If this is adding, that's going to be wrong. So there's no adding, just multiplication, remember? Okay, therefore, none of these properties applies here. They don't. None of them applies here. Only the negative exponents applies here. Only the negative exponents apply here. You guys follow me? Okay. Only the negative exponents applies here. None of these applies here. Only this one applies. Okay. But this one, we can use that property. Okay. And we can also use this property. Okay. So you need to watch carefully. Between the change of positive sign and multiplication sign, it makes a world of difference. So let's move forward. How do we, okay, so first you recognize the difference. Different from that. The difference is very subtle, but there's a big difference. That difference makes a big difference. So how do we simplify this first piece? Okay, we have to follow the order of operation. We have to follow the order of operation. Okay, how do we follow the order of operation? Okay, we have to leave out the exponents outside there. We cannot do it yet. So we're going to transform this to 1/2. And this is going to be 1/3. Right? We apply the negative exponents. We apply the negative exponents. Okay, so what we applied that property over there. Okay, and next, we are going to find a common denominator. Okay, so we're going to find common denominator. What is a common denominator? The common denominator obviously is 6. So 6 under 3. And this is going to be 6 under 2. All right. Now, inside the parentheses, we have the same denominator 6. And 3 plus 2, that's a 5. And then raise to the power of -1. Afterwards, now we can apply the -1 exponents. Okay. So we're going to have 5 to the power of -1 over 6 to the power of -1. Well, we didn't mention there's a similar property, okay, which is not difficult to prove, is that when we have A over B raised to the power of n, okay, so it can be derived similarly to this property, Okay, it's very similar. Okay, similar to that guy. Okay, so then we're gonna get A to the power of n over B to the power of n. Okay, so now we're gonna apply the negative exponents one more time, and we're going to get a 6 over 5. We get 6 over 5. Okay, so now we're done with that. And do we have to do it this way? Yes, absolutely. You cannot apply the exponents outside to the inside. But on the other question, however, we can. So I'm going to show you 2 different ways to do it. 2 different ways to do it. The first way to do it, okay, The first way to do it is that I'm still going to take these properties along with us, right? The first way to do it is that we do similar to, we can do the inside the parentheses, right? So we're going to have half multiply third right? On outside is -1 as the power. So 1/2 times 1/3. 1/2 times 1/3 is 1/6. Numerator times numerator, denominator times denominator. And then outside there's a -1 as the power. Okay, and of course, there are more, at this point you can also write 6 to the power -1, that's inside. And then outside is -1 as the power. Now you can multiply these two powers if you wish. Okay, you can multiply these two powers, 6 to the power of -1 times -1, which you're applying this property. Okay, and of course we know that -1 times -1 is 1, so that equals to 6. Or there's another way to do it, which is, okay, we can apply that property. We can apply that property. How do we apply that property? You see, this is A, this is lowercase a, lowercase b, and the n is -1. So we can distribute the -1 to each one of the bases. So you're gonna have, okay, we're gonna have, if we apply this property, we're getting 2 to the power -1, which we had before. And then outside to the power of -1, because that's from here. That's from over here. And 3 to the power of -1, and then to the power of -1. You see that? By applying this property, And now, why? Because this is a multiplication. This is a multiplication. Oops, the dot. This is a multiplication. That's why we can apply it. Okay. So now we could get 2 to the power -1 to the power -1, and then we can apply this property one more time. We can apply this property, right? So -1 times -1, these two powers multiply. One is m, the other one is n. So we're gonna get a 2, and then we get times 3, and of course that equals to 6. So these are the two different ways you could do it. Okay, if it's a multiplication. In the first case, we cannot, so what we can apply from these properties is very limited. So we have to do it from inside out, following the order of operation, Okay, so let's see. Do we have another example? Okay, so let's do another one. Okay, let's do a subtraction. Okay, so this is number 6. I'm looking at number 7 and 8. Okay, I'm looking at number 7 and 8 in the homework. Okay, so what we have here is 4 to the power of -1 minus 7 to the power of -1. And there's a -1 in the power outside. Okay, so can we apply any one of these properties? No, we cannot. There's a subtraction. None of these formula involve subtraction like that. like that in that situation, okay? So what we can do here, we're gonna have to do it from inside out. For the negative exponents, of course, we can apply the proper, the definition of a negative exponent. So over here, we're gonna keep the parentheses, the powers outside, and this one is gonna turn into a quarter. And this other one, that's gonna turn into a 1/7. And then we're gonna find common denominator. What is a common denominator? Well, the common denominator is 28, 4 times 7. So over here, we're gonna do a 7/7. We're using property principle number 1, right? Anything times 1 stay the same. So I'm gonna have 4/4. Please do it alongside with me. And at this point, we're getting closer because this is gonna give us 28. So 7/28, right? And on this one, we're gonna have a 4/28. Okay, and now we have the same denominator, which is 28, we keep it, and 7 minus 4, that's a 3. But outside of it, there's a -1 power. And in the end, okay, we use the property one more time, and we're gonna have 28/3. Okay, number 8 by comparison, just a change of a symbol, subtraction turned into multiplication. See what that happens. What happens then? On this one, we can apply many of the different properties we have here. We can apply a lot of those properties, okay? And of course, you're not gonna apply each one of them. You just try to keep it simple, right? You can try to keep it simple. And which property would be most beneficial and get it done quickly. And this will be the property I would use, right? So you're gonna have 4 to the power of -1. And then there's a negative sign, there's a negative power outside. Multiply 7 to the power of -1. Right, and then to the power of -1 equals to 4 to the power of -1 and then to the power of -1. So we can apply that property. Right, we can apply that property. So that's going to be 4 times 7. That equals to 28. And of course, this is not the only way to do it. Okay, so this covers the fractions. This covers fractions. So we're going to do one more, which is number 11. Okay, now the power is not a -1, it's like -2, right? Or -3. So number 11 on your homework. Okay, so 2 to the power of -3 plus 3 to the power of -2. And then outside there's a power, -1. And we know we cannot apply the -1 power inside. We have to wait, right? So we're gonna have to wait. 2 to the power of -3 according to the power for negative exponents, right? The power for negative exponents, right? So 2 to the power of -3 now is going to turn into 2 to the power of 1 over 2 to the power of 3. On the other one, what are we getting? 3 to the power negative 2, that's turning into 3 squared under 1, right? So that's what this negative power tells us. And then afterwards, the negative 1 exponent has to wait outside patiently. 2 to the power 3 is 8. 3 squared is 9. And we're going to find the common denominator. And what is the common denominator? 8 times 9, 72, right? So I'm going to multiply by 1. Principal number 1 is used. Anything times 1 stay the same, right? We'll multiply by 1. So this is going to be 8 over 8. Nothing changed, equal sign justified. So next we're getting to over here, the power is still outside waiting patiently, right? So we have 9 over 72 plus 8 over 72 equals to, we got the negative 1 power. Now, 9 plus 8 is a 17, and the denominator 72 stays there. Now we are going to apply this negative exponent one more time. And so the final answer is 72 over 17. Okay, so that's the exercise number 6. You know, we've done some examples, and let's see anything else that we would work for you. Okay, let me know if you have any questions. Okay, thank you for watching.